All right, welcome back. Again, we're going to take a look at using arrow diagrams to write the inverse of a function. So we have a function here that it's not completely straightforward, and we're going to take a look at what the inverse of that function would be. The traditional method for doing this would be to replace the f of x with an x and the x with a y, and then solve the whole thing so that it says y equals. Okay. And there's certainly nothing wrong with that, but I just want to show you how the arrow diagram can do that as well. It is important that we have a pretty straightforward transformation of functions that have inverses. So we do have that here. But the first thing we're going to do is make the arrow diagram. Okay. So I will do that here. I start with the x. It needs to get a negative in front of it, so I'm going to sign change that. I want to make sure that I don't put anything on an arrow that I don't know for sure what the opposite of that arrow is. That's going to drop a negative x right there, so then I need to add a 1 to make it a 1 minus x. Then I will flip it over. There's a couple of things I could do at this point, but this is the one that I'm going to choose to do. So that gives me the 1 over 1 minus x. Multiply by 2 to get that 2 over 1 minus x. And then I need a negative in front of that, so I'm going to sign change over this way to give me a net minus 2 over 1 minus x. And then we'll add a 3 onto that, and that should get me down to the end. Okay, so I've verified this along the way. I'm going to get some of this clutter out of the middle because the arrow diagram really doesn't require this stuff in the middle to be there. And in fact, I'm going to get rid of the x on that side. This sequence of arrows in this particular order represents this function that we were looking at up here. Okay. Modeling what goes on in the traditional method of doing this, we're going to switch the places of the x and the y. So we're going to say, well, what if this was the input? And so my final destination then is to get over here. Okay. Well, I just make the arrows going back. This is going to be an x minus 3. I could make them dotted. I'm not going to continue to do that anymore. Opposite of a sign change, or the inverse of a sign change, is a sign change. The inverse of multiplying by 2 is multiplying by a half. The inverse of the reciprocal is the reciprocal. The inverse of adding 1 is subtracting 1. The inverse of the sign change is a sign change. And so now I just do what it said to do. I put the x into this set of parentheses here. It becomes an x minus 3. Change the sign on that. And it will become a 3 minus x. Multiply by 1/2, I can do that by putting the 2 under it. And then my next step here says flip it over, so that becomes a 2 over 3 minus x. And then subtract 1 from that. And then change the sign on all of that. So I'll change the sign on all of it, distribute that through there, and flip them around so I'm not leading with a negative, and it becomes 1 minus 2 over 3 minus x. This is my inverse. So that was the goal of this problem, was to figure out what the inverse of the function was, and I just followed the arrows backwards. The beauty of this also is normally we want to prove that it's an inverse by doing a composition of the function, the inverse with the function, but that's already here in the arrow. Okay. If I start with my x on the far right and I follow it along here, then I end up on this end. My y, I said, was going to be 1 minus 2 over 3 minus x. And if I then follow the arrows across the top, by the time I get down to the other end, I'm going to be back to x, and I know that because the arrow diagram proves it in the first place. So the arrow diagram is its own proof of the fact that this is the correct inverse. Okay? And so as long as we know how to draw these arrows coming back, then we can write the inverse of any function this way. Okay? And it is fairly important that we end up with something where the x just shows up one time in this. There are some functions where the x shows up more than once that you are able to do an inverse. Usually means that there's some kind of algebraic manipulation you can do to it to make it only look like it has one x along the way. All right, so that is how we use an arrow diagram to write an inverse.